Okay, so today we're going to start talking about volume of prisms and cylinders. Okay? We'll talk about volume. So let's flip back over here. For a prism, just write these down again real quick. Volume equals V times H. For a cylinder, volume equals pi squared times H, which actually these two really are the same formula. Why are those two really the same formula?
Because the area of the circle is pi squared.
Exactly. On this one, just being more specific, really, because with a cylinder, what shape is the base always? It's always got a circular base. So the way you find the area of its base is always going to be pi squared. Whereas on a prism, it can have a triangular base, it can have a pentagonal base, it can have an octagonal base, and just going on forever. So on this one, it's just more generic. You're just saying you're finding the area of whatever kind of base it has. On a cylinder, you know it always has a circular base, so you're always going to use this for that. Okay, so on this one, rectangular prism, so we're going to assume that the side that it's laying on is the base. So what is the capital B for this thing? Is 14. Because capital B is the area of the base. That's a rectangle. Length times width, 2 times 7 is 14. Okay, what's the height of this prism?
1.
Is 1. That's the distance between the bases. Now, what's the volume of it?
14 cubed.
Okay, good. So we do B times H. Yes, and volume is cubed. Volume is cubed. Okay, so why is volume cubed? Okay, so when we have centimeters, centimeters squared, and centimeters cubed. Okay, centimeters is just a linear measurement. No, centimeters squared is a two-dimensional space.
Oh, three-dimensional.
And cubic is three-dimensional space. Because if you think about it, centimeters to the first are just centimeters, it's just a linear measurement. It's only left, right. That's one dimension. Centimeters squared has two dimensions. You can go left, right, and up and down. Centimeters cubed, you can go left, right, up, down, and forward to backwards. Okay, that's one way to think about it. Another way to think about it is, I'm going to do the same thing with this. I'm not going to say centimeters cubed, although that's fine. I'm going to say cubic centimeters. Cubic centimeters is the way I'm going to say that, because what would happen is if you had a centimeter, a cube that was a centimeter by centimeter by centimeter, it would take 14 of those to fill this thing up right here. All right. What's the radius for this cylinder? 6. The height is 8. Volume is pi r squared times h. 904.78. All right, cubic meters. Excuse me. All right, on this one. So capital B stands for what?
Area of the base.
Area of the base. So how am I going to find the area of this base?
6 times 8 divided by 2.
6 times 8 divided by 2, which is 24. What's the height?
5.
It's 5. And so volume is area of the base times the height. 120 cubic centimeters. All right, on this one, capital V is area of the base. So how am I going to find the area of this base right here? Good. Apothem times perimeter divided by 2. So we're going to have 7.79, which is the apothem, times what's the perimeter of that pentagon? 45 divided by 2. 28. Okay, what's the height? 10. And so we're going to take area of the base times the height, which should be 1,752. 1,752.75 cubic yards.
Oh, no, not this again.
Yes.
No.
Okay, so on this one, so we need to know the apothem length on this. Okay, I'm gonna cut out a few little steps that we did yesterday, but on this hexagon, this angle right here is 120 degrees. The whole angle is 120. So how big is this angle going to be? Half of that is going to be 60. This is 3 because it's half of 6. This is the side I'm looking for. So we have H, A, O. So I don't need the hypotenuse, so this is tangent. So tangent of 60, which we could use special rights here, but we're going to go ahead and do true. So tangent of 60 equals the opposite x over the adjacent 3. And since the x is on top, we're going to multiply. So I'm going to do 3 times the 10 of 60. What is it? 5.2. I mean, go ahead and just tell me the number that it says.
5.196.
Okay, yeah, 5.2 will be good. So there you go. The apothem is 5.2. So to find the area of the base, we're going to take the apothem 5.2 times what would the perimeter of that hexagon be?
36.
It would be 36.
So 93.6.
It's what?
93.6.
And then what's the height of this prism?
60.
And then we're going to do area of the base times the height.
1,497.6. That's good, so we know.
Let's go ahead and turn over to the back like we've been doing the last couple days. So for the last 3 days, we're doing Monday. Last 3 days, I think we've been talking about surface area. Okay, so I just want to talk about that for a little bit and volume to talk about the difference in these two. So what is surface area? What are we finding when we're finding surface area?
Everything.
Okay.
Area of the surface.
Okay, basically yes. Okay, we're finding the area of the surface. Okay, and emphasis on the word surface, obviously. Area of the surface of the object. So what does the word surface mean? Okay, yeah, like surface is like the outermost layer.
Yeah.
Okay? So, as an example of this, just so we can have in our mind what's going on here, the difference between these two. Surface area, an example of this would be like, I don't know, this is one I just thought of, is like wrapping paper for a gift. If you have this box, this gift that's in this box, and then you go to put wrapping paper on it, that's basically like the surface area. It's just on the outside of that solid object. And that's what we've been talking about. That's the formulas, those formulas right over there. That's what you just used on the quiz you took, is for doing that. It's for finding the area on the outside surface of that object. Okay? But today we're going to talk about volume now. So what is volume?
Everything inside.
Okay, that'll work. All right, so volume is everything inside the object. Okay, and so obviously emphasis on the word inside, which is opposed to the word of surface area, surface, which is, on the outside. So as an example of that, this is the easiest one for me to always think about. It's how much water in a glass. Okay, if you had a cup, it's how much water it takes to fill that cup up. So that's what we're going to be talking about today, is volume. Now the good thing about this is really the volume formulas are easier than the surface area formulas. There's really, it's just easier to apply these. Okay, so for a prism, the volume formula is simply this. Volume equals capital B times little h. And all of these variables mean the same thing that they mean under surface area. So what does the capital B stand for?
Area of the base.
Okay, so capital B stands for area of the base. All right, so in this case, it would be the area of this hexagon. And this one would be the area of this hexagon. And this one would be the area of this triangle. And this one would be the area of this triangle. And what does the little h stand for? Okay, good. It stands for the height, which more specifically, exactly, is the distance between the bases. Okay, so from here to here would be the height on this one. From here to here would be the height on this one. From here to here would be the height on this one. From here to here would be the height on this one. All right, and then volume of a cylinder. Okay, so this is pi r squared times h. So there's a lot less to remember. And on surface area, we have lateral surface area and total surface area. Well, with volume, if you're talking about just filling the inside of it up, there's no way to do that differently. There's no other way to slice that or whatever. I mean, the volume is just the volume. So there's not different types of volume. It's just what it takes to fill that thing up. So you don't have to think about is this lateral or total or anything like that. It's just always going to be the same formula. Okay?